Hello and welcome, everyone. My name is Sanjin, and I'm here with Zach Stuffy. I am a teacher of about 10 years. I've been teaching coding in various tech subjects. Stuffy is a bona fide hacker, initially self-taught, and he's completing all sorts of qualifications and has worked for the military, and you're now in private security industry, right?
Yep. Yeah, I now work for a civilian company as a cybersecurity engineer. I've worked there for a couple of years now.
Awesome. So like what these walkthroughs are going to be all about is that I do not think, as far as we've looked, as far as I've been self-taught for about the last 3 months, that there really is a nice roll of breadcrumbs for beginners to get into security. The coolest resource I've seen so far that's free has been the picoCTF. So this is a capture the flag competition designed for beginners. For high school students. However, each challenge has a lot of concepts to unpack. And in my teaching experience, when students grapple with a hard problem for a while, and then they get to see the solution, that just tends to stick so much better. So we are hopefully going to design and create some well-elaborated and discussed solutions. And the way we got together is I got in touch with Zach because his walkthroughs actually gave a lot more background than most. And I thought I'd love to work with this guy and sort of create something. So personally, I'm working on a coding competition that's taking place at the end of the year that's going to have a cyber twist. And hopefully this will be a useful resource for the students. So Stuffy, what I've got here is my picoCTF web shell. I've logged in. We've got, I think, 15 problems to get through. I'm going to be solving them, and I'll be leaning on you for help and explanations, more importantly. So what I'm going to do is create a directory here, something really short, so it doesn't take a lot of screen space. And these problems are from the general, actually, I'm just going to go into general skills. So these are general skills category. So essentially, I'm going to call this GS. And I'm going to go there. And the idea here is that we're going to do a bunch of capture the flag challenges. These are the easier ones that are going to use some basic Linux commands that are going to be handy. So what's the first one? Let's click on it. Obedient cat. So this one has a flag in plain sight. And the hints are entering terminal, such as the next one. We'll start with everything after the $sign. So I guess it describes the web shell terminal. What exactly, so like this is a user at, this is sort of like a organization or computer name.
Usually that's the host name, yep.
The host name.
You can change it. You can set those variables in your own machine if you use your own. I didn't, when I did these same CTFs, I actually used my personal machine. I used Parrot OS, and I used it. All I did was open up my VM and then download the flag manually rather than do it that way. But you can do it either way.
Yeah, I think I would say like for beginners, like if you've never installed like a Linux virtual machine or you don't have like a Linux machine nearby, I think just using their terminal should be fine.
Yeah,
I'm pretty sure that like other than getting into root folder, I'm not sure you could like download packages, but everything required to solve these is supposedly already on there.
Yeah. So
let's have a go at using their web shell and see how far we get. So this says basically use wget. Now, the link that they gave us is the same as that. Now, if I was to click download flag, that would actually save the flag here, and then I could open it with some text editor. But what they want us to do is copy the link from here, copy link address, Control-Shift-V paste. And now if I press ls, that's going to show me what's in there, and I can open that flag with cat flag, and that's our flag. Now, cat opens files in a way that you see them in basically in your terminal. Nano. And let me ask you a question, because I've been struggling with this Nano.
Yeah.
So Nano is like a text editor, but the mouse doesn't work on it, even in.
It's very old. Well, not old. People still use it, but it's a very original to Linux. I use VI or VIM, whatever you want to call it. I'm sure this box probably has VI if you use it.
Okay.
It's even more complex to use as far as you can try Vim. But basically these are traditional text editors that are Flag, I believe is just Flag. Yep.
Yeah.
These are traditional text editors that are So to actually start typing, you have to hit I. That'll insert where you're at. Then you have to hit escape. To save it, you have to hit :WQ. It's a whole thing.
And what do I need to click? What do I need to click to exit?
So, to exit, you hit escape once. That'll take you out of editing. I don't know if you hit I. Now you just you type :.
Oh my God. :
And then WQ will, or just Q. WQ will save it and quit. So these are just text editors that are based on the old Linux or Unix machines. Linux is actually just Unix that someone else basically thought was a better version of it. But yeah, these have been around forever. So you can look up cheat sheets and stuff. Even I use them all the time, and I still have to pull up cheat sheets sometimes because there's certain things you're trying to do that, like you said, the mouse doesn't work and you're trying to figure it out. So
Stuffy, I've got one question. When you're writing code, actual whatever it is, Shell or Python in Linux, do you use your mouse?
Not really. It just depends on what I'm doing. A lot of Linux OSs nowadays have GUI interfaces, so it's not like you're gonna very commonly, if you're on your own machine, if you're SSHing or logging into a server, typically you're not gonna have a GUI. But if you're on your own machine writing code and stuff, you pretty much have access to your mouse just like anything else. But it just depends on what text editor you use.
So I guess we've opened the first flag, and the first tip to give to users is get used to coding without a mouse, because that will be necessary sometimes.
Linux is very good about if you're trying to learn how to get away from using that mouse all the time. Linux will help you a ton.
I've noticed. Okay, Stuffy. So we got a bit of Python. We were talking about Python, and this gives us 3 pieces right here. There's a script, a password, and a flag. So we're going to wget all of them. Copy link address, and then wget password, and wget the flag. And then we got all 3. Just going to, okay, so we got all 3, and let's begin by having a look at the Python scripts. So I've used cat. Yep.
One thing I'll say, obviously this web shell they've created is designed for this, so they've already got it implemented. But if you did this on your box, typically, a lot of boxes, if you downloaded a script like that you're going to run, Python's different. Python is ran by the Python command. But if you were to run, just download a file, typically it's non-executable. You usually would have to make it executable. So sometimes you might download that and it might say you have invalid permissions, or it won't allow you to run it. Like I said, Python's a little different. It allows you to run it with the Python command. But if you were downloading like a bash script or something like that, you have to change the permissions on your system or else it won't run. And you'll be sitting there for a while trying to figure it out.
Right. And generally speaking, if you run cat on any type of like code file, so let's say it's the whatever other language, it's going to show you the code, right? Like the actual code files are really just text files. The only difference is in Python, you can actually execute them with a Python 3 command, and everything else you generally need to compile. Okay, so let's just go through this and try to unpack what it does a little bit. So there seems to be an argument here for encryption and an argument for decryption. The decryption asks you for password. It's looking for data. So I'm guessing it's going to be using the password and then reading the flag. Yep. So the flag is, we can actually cat the flag. It'll be some jumbled up encrypted text. It'll be interesting because they're using some type of cipher. And if it's exactly the same length, then we'll kind of know if it's a substitution.
Yeah,
so,
I see base 64 in there too. So that kind of makes me think that it's base 64 encoded, which isn't very strong. So you could probably just decrypt that, but we'll use their script.
We'll use their method, and if there's if you know a name of tool and they have it in there, we could try something else. So all right, how is this going to work? We're going to call the Python script, Python 3, and we're going to call I think it was md.py, and we might run into some trouble. Like, I'm not sure if flag is going to be a parameter. Let's try without it. So we're going to do the decryption and we're going to enter the password, the password. Let's give this up. And then we're going to cat. Was it password?
I think it was just password. Yeah. You can always tab to ensure that you've got it correct.
Right. So that's the password. Bingo. And now we're going to try that same command, Python 3 encryption. And now we enter the password. And the error here says with open. So it's expecting to open a file. So this would indicate that the actual flag, the encrypted material, is one of the parameters. We're just going to go ahead and type it in as a parameter after decryption. So we're just going to do the same thing. And then this was going to be, this is going to be tab. I'm going to take C, md.py. Oh, I'm pressing the tab again. And these are all the options.
So if you back up a little bit, get rid of the end, because you got npy in there twice.
Oh.
There you go. Now,
if you just type,
if you just hit F and then tab, it'll finish flag.txt for you. So that's how you know you're typing it correctly. It may, yeah.
It didn't finish it, which worries me.
It's not incorrect. It just means that basically it's not recognizing it as whoever wrote this code didn't completely fill it, basically.
Right.
If you write everything correctly, then it will allow for auto completion, but some things won't. But we could tell in that they didn't.
Now I am a little bit stuck again. Okay, so we've got the perfect parameters, but I don't have the password in the same thing. So I gotta go cat pw.
Yep. So you can do it right there, and you can pipe it in like we did.
Well, let's give that a go. All right. So so this is pw.txt is what we're piping.
So, well, you'll have to cat it first to open it.
It's there.
No, you'll have to put cat pw.txt. Then when it opens, it doesn't just put it on the screen. It'll actually push it into whatever command you're piping.
So basically,
the pipe just takes the input from whatever command you typed before and pushes it to the command that you're typing next.
So any type of program that has a text input, the text input is going to be whatever is in pw.txt.
Yep.
It will execute, it'll hit enter on that text input so that we don't hit enter. And we're going to see the output of that being,
it'll take that std out is what it's called. It'll take that string out and it'll push it to whatever argument that it's looking for here.
Cool. md.py.
And you can do that with more than just catting stuff. A pipe automatically will take whatever the result of this is. So for instance, if you were to nmap something and look and try and scan a target, you can then put a pipe in grep so that it gets rid of everything except for a specific keyword search that you're looking for. It just takes the results of whatever you typed before and it pipes it into the next command that you're giving it.
I imagine you use that a lot.
You do, yes. Yeah, the pipe is very useful.
Okay, so are we on the right track? Oh,
there you go.
All right, we learned how to use pipes, which is very handy. And here we go, submit the flag. We are in. If we didn't use pipes, if we did it the old way, we would be asked for the password here. And I would then copy it from there because we have catted it. And then we would enter it there and we would have gotten it without the pipe. So just showing you guys that, okay, yes, the pipe added an extra cog into the machine, but it's certainly going to be handy down the road. Super. That is 2 down. Where is our master file? We're going to be waving a flag next. So I'm just going to get out of this directory. And we're going to create a new one. Make there. And I'm just going to use wave a flag like this. CD WAF. Okay. So you can invoke help flags for a tool in binary. This program has extraordinarily helpful information. So let's get this program and have a think about it. So we're going to wget. Take a look at that. ls. It's called warm. Now this, again, as sort of a person that's used a lot of computers, I'm not used to seeing no extensions on files. Yeah. Like if I'm in the terminal, I expect to see file extensions. Like, what should I be thinking when I see this?
So Linux is one of the great things about it is it does what you tell it. That's one of the great and bad things about it. Meaning you can take any file and make it an executable in Linux and it will try to run it. It'll give you an error because it doesn't know what to do with most of them, right? If you just tried to execute everything. But so if you type ls and then hit space and then do attack, which is just the little dash, that's what I've always learned. It's called attack.
This one? No.
Nope, just the straight one.
This one. Attack.
Yep, and then LA.
La.
This will give you, so you notice we've got warm file there. It's read write only. You see it says RW. So it's read write only. So you actually can't execute it right now. You have to do a change mod, which is chmod. This is how you change permissions.
Right.
And hit space and just do a 777. So basically that adds up to giving read, write, and execute to everybody. I'm not really sure. Oh, we didn't specify which file.
Obviously. So that's going to be.
You would put it after the 777.
Oh. So.
And it's just warm. Yep.
I've used this before for -X to make things executable.
Yeah, you can make it. Yep.
And now warm is turned green.
Yep. So now you can execute it.
Okay, which was
so now it's period. Yep.
Wait, I think it's like this. Warm. Is there a space?
Nope, there's no space.
Hello, user. Pass me a -H. Well, an attack H. Negative H just sounds bad.
So so now you just do the same command, but afterwards put a space and put the attack H, and that will basically, so anyone that writes a Linux program should put attack H parameter on there, and that's usually the help menu. So every program in Linux that comes default should have a help menu. Sometimes if you download them from GitHub or something like that, they didn't complete one. That means they just didn't put the work in for it. So sometimes if they're still working on the program or something like that, they won't have the H menu, but usually there's an H menu that's for help.
So when you want to do something, like you execute it, and you write H, that's going to basically give you execution instructions. But if you were doing some other command, doing -H, that will explain what that particular command is supposed to do.
So like for instance, if you, for cat, so type cat with nothing on it, just hit enter.
Cat. Oh.
And it should tell you. Well, if it loads.
Control D.
Yeah.
If I do cat with no space. Yeah.
Okay, that didn't work. Just type cat and you can do -H, or you can do there's also what's called man pages, and it might be --help, just depends. Yeah, so there's --help. It's the same thing. So every command in Linux has this, and it's going to give you what arguments you can pass to it. So you can see if you did cat with a capital A, it's going to show all, that type of thing. So every command in Linux has this. So if you ever get stuck on something, you can't figure out what you're trying to do, you can type or the --help, or some of them, like I said, if they're files that you downloaded, you can do it with a -H menu. Really, and then there's also what's called man pages, which are similar, but you would type man and then the command, and usually that's going to give you a much more detailed help menu.
Awesome. All right, we are now on to nice Netcat, and then we're going to do what's a Netcat, because I'm grouping the Netcat ones together. So when I click on nice Netcat, it says there is a nice program that you can talk to by using this command. So I don't think we need to create a folder, because Netcat takes us somewhere outside of our directory, right? Like this goes to some, this is a lot of fun. So this, like when you type this command, right? NC Mercury dot, okay, so what is this, a directory on some server somewhere? Like,
so Netcat is just a tool to connect. It uses whatever protocol it's trying to connect to. So for instance, if you do Netcat and you're trying to connect on a telnet server or something, that's the command you're going to use, is whatever protocol you're using. So Netcat itself is just designed to connect. It's just a connection tool. It's going to reach out and ask for permission. They obviously have it set up for listening. So once we hit their side, they're already waiting for us. They're going to send back whatever information it's told to. We also use Netcat. I personally use Netcat almost every day, but that's because we use it for reverse shells. So meaning I'm going to set up a Netcat listener, and then I will tell the server I'm attacking to then reach back to me, and that sets up our shell. So now we have a connection, because most firewalls will block incoming, right? So if I tried to connect to some random port incoming, it's going to get blocked. But if I can talk to a computer inside and tell it to connect to me, it's not going to get blocked.
Aha, interesting. So like, is it very easy in Linux to set up a directory that other people can Netcat into or SSH into, or is that something that's like a bit on the advanced side?
It's easy. I'll tell you that there's actually a better tool for it. If you're just trying to pass information very quickly. So the big one I use all the time is Python. Python 3 simple server. It feeds so you can just run a Python 3 tac-im http.server, and then on whatever port you want, and then you can go to any web browser and type in your IP address, and there's your whole directory, and you can download it from any computer on the network. So that's typically how I serve up most of my files. If I'm just passing them real quick to from computer to computer, it's much easier and very simple. And then when you're done, you just turn it off and you're done.
Very encouraging for me. Again, like anything you can link to Python is actually something that I feel like I've got a bit of a leg up.
Yeah.
And again, most students I teach in Australia, 7 to 10, everybody learns Python. So like with these challenges, the more, so like we need to talk about the challenge. These I bet are, given their number is between 0 and 255, ASCII keys. So
most likely, yep.
So if I search for like ASCII table, and this is fun, I always talk about these to students. Like any key is an 8-digit binary number or a number between 0 to 255, and like that's basically your keyboard encoded. I think that every combination, including shift and function, of every key fits on the 255. I could be wrong about that, but I think that's all the keys you could type in.
Yeah.
If you want to go beyond that and do emojis and stuff, then there's like Unicode tables. So
yeah, I don't mean to cut you off. That's one thing some people get confused on some of this, especially when you start doing like ASCII keys and like encoding and stuff. The easiest way I try to explain it to people is it's just a standard that we came up with so that everyone's on the same page. That's all it is. It's a way because computers can only talk in binary, so they have to be associated with a number. So it's just a way that we came together and said, this is what we're going to use. And that way everybody's on the same page. And a good example of this is iPhone versus Android. If you have an iPhone and you send an emoji to someone on Android, if you've ever gotten that little, it pops up, but it doesn't look right, it doesn't make any sense. That's because Android standard versus iPhone standard for that emoji, they have different binaries, so they're not going to accept it. So that's what happens when you don't work together. It doesn't communicate versus something like this where the whole world said we're going to use this.
Right. And ultimately, like, it's not an accident that the numbers are from 0 to 255, right? Because it's a standard unit of memory. It's a byte, 8 ones and zeros, 8 bits. And I guess it's a bit arbitrary whether you start with ABC or you start with some other characters, but it was always going to be the keys of the keyboard, and we're always going to get encoded into a number from 0 to 255. So if I go and search for ASCII converter, there's going to be so many options. Is there any that, like, I'm sure you like hit a website like this at least a couple times at least?
CyberChef is by far the best tool out there. It does. Is that
a website?
Yeah, it's got its own online website. It's got it comes on almost every Linux that distro, like Kali or Parrot, that's for hackers. But you can see there, so you put the input and then you just choose what you're going to decode it with. So you just up there at the search, you'll do whatever it is.
So if I search for ASCII, okay, this is way more. This is already way more complicated than most of the easy ones.
You can do just ASCII converters, and those work just great as far as like for different tools. But this is the best all-in-one tool because you can use it offline as well. But you can see if you go down to decode text, I believe.
So show me how to get essentially. All right, 1 second. I'm just going to go and duplicate this tab and use an easy tool to make it easy for people. Text ASCII converter. I'll just press the first one. I'll paste that in. And ASCII numbers to text. Really? That makes no sense. All right. We'll go to the second one and see if we could be wrong. It might not be ASCII. Not convert to ASCII. I think we need to go convert characters to ASCII codes. We need to go ASCII to text. ASCII to text. Convert. And convert. There we go. So now that we got the easy way out of the way, please go ahead and try to help me decipher the CyberChef website.
Over on so first thing that I always try is see down on the favorites, there's the magic one down at just below. Yep, that's going to try and figure it out for you. So it's going to look at it, the code, and say this is XYZ, and it's going to try. So you just drag it over to the recipe.
Oh Lord.
And then it'll tell you basically if it can figure it out or not. It looks like it can't, is what I'm going to say, just based on the entropy. But so you can go ahead and hit the trash can up at the top. That'll get rid of the recipe.
Okay.
And then search the ASCII again. All right. And then see where it says decode text.
Mm-hmm.
So you drag that over. And then there's a drop down on the UTF there where it says UTF. you'll click it, and you'll go down until towards the bottom, there'll be the ASCII. And I know this is much more complex, but this is just an all-encompassing, all-in-one tool that will allow you to.
Atari, Arabic. Oh my God.
I know it's in there. I just don't know what the actual name is here.
I mean, it's interesting because you could have the same thing running by a different name, and ASCII is probably some type of an ISO standard.
Yeah. There. Oh, I saw it. It's under US up a little bit. US ASCII right there. There you go. And hit bake. See if it pops anything out. And it may not. Doesn't look like it's gonna figure it out. I'd have to go through and figure it out. I did do it earlier using CyberChef, so I know it's in there, but it is more complex than some of the easier tools. I'll say that. Go ahead.
I'll tell you what, we're gonna try the CyberChef magic because we have like 5 encoding challenges in a row, and we're gonna try the CyberChef magic on those, and we'll see how it does. But yeah, the core of what we went through here is that we got ASCII being, if you see characters, if you see encrypted stuff and all the numbers are between 0 and 255, it's basically ASCII, and you can get ASCII to text, and that'll get you out of there. I did copy this flag.
All right, so I did figure out I looked back at my notes. I did figure out which one I used on CyberChef.
Cool.
Which recipe, I should say.
So we can go back and do that. 1 second, I'll just. Okay.
Yeah. So if you go back up to get rid of the ASCII, and it'll be from decimal is the one I used. So from decimal right there, drag it over, and then it'll ask you what you want to. There you go, right there. So it figured it out for you. So the space is the delimiter. So if you put a commas in there, you can change the delimiter. But there it popped it out. So yeah, so CyberChef is a great tool. It does take some more finagling than some of the other ones, but it can do a little bit more complex algorithms later on. Obviously, these are pretty simple, so you can use a simple converter, but it can do some like hashes and stuff like that.
And Zach, you could use CyberChef in the command prompt in Linux. In fact, that's where you use it. Is that right?
I've never really messed with it in the command line. I'm sure you could, but it comes on every Linux box that uses Kali, Parrot, any hacker box. It usually is downloaded offline, so you can open it in a web browser regardless.
Okay, cool. Because I just thought like the GitHub repository, and generally things with GitHub repositories are executable in text, particularly.
Yeah, there probably is a way. I've never really messed with it because I've never needed to. I've always had the GUI interface.
Cool. It's good to know that like a hacker prefers the GUI interface sometimes.
Yeah, definitely on some things, just because you can see how many options there are. It'd be tough to memorize every syntax for that.
Okay, so the next one is called What's a Netcat? And well, this one's got 100 points. And if I was going to criticize picoCTF on something, it would be some really hard challenges are worth the same points as some really easy challenges. So for kids out there like getting frustrated, like this is only 50 points or 20 points, but it's hard. Don't think too much about the points. Oh my God, like see, this one was worth more than the last one.
And it was way easier, yeah.
And this was way too easy. So I'm just going to paste that there. And I guess
one thing I will say about Netcat, it's used all the time, I would say daily by most hackers to do reverse shells and things, but there are a couple downsides. Number one, it's not secure. So there's whatever you're transferring over it, unless you're using a secure protocol and having it encrypted before it's hitting that reverse shell, it's going to be coming over plain text. So if you're using it for correct purposes, meaning you're just trying to transfer files and things like that, that's all going to be plain text. So someone can intercept that. The other big thing is Netcat shells are only as good as whatever service or whatever you're grabbing a hold of. So what I mean by that is whenever you take over a box, you're impersonating typically a service, right? So whether that's PowerShell or whatever, because unless you're just you've got some credentials and you log directly in using SSH or something, you're impersonating a service. Netcat is only as good as whatever service you're impersonating. So what can happen a lot of times is you have this Netcat shell and it's working great, and all of a sudden it crashes, and then you have to do it again and it crashes. A lot of times you'll see this with Netcat because Netcat is only as good as what you're connecting to. And a lot of people think it's a Netcat issue, and it's not necessarily a Netcat issue. It's typically when you get a reverse shell in general, the first thing you're going to do is stabilize it. And that's a little bit beyond the scope of this, but I just wanted to point out that Netcat does have a few downsides as far as when just trying to do reverse shells and things like that.
So like if you are, as far as you using it, we're talking about you being on your own secure internal network and transferring files between sort of machines of that network. That's where you use it. It's kind of like
I don't use it because it's unsecure. So I personally would just use secure copy, which is just, it uses SSH. SSH is secure. So I personally just use secure copy. But you could easily use it. Yes, you could. It's just, that's the big downside is it's an unsecure protocol. So therefore it's going to, everything you transfer is going to be in plain text. If someone theoretically was listening, they have a hold of it.
So generally speaking, let's say you got, I don't know, 4 computers at home and you're transferring some media files from computer to computer. You would take the precaution to do that in an encrypted manner.
I would just because of how simple it is. Secure copies just as quick as Netcat. There's no reason not to.
Okay.
I also, if I'm not so much worried about security, if I know, like for me, I live away from the city and stuff, so I know there's not really anybody hanging out, I would still use the Python simple server. It's just much easier, much simpler. Netcat is just it's been around for so long. It's almost an outdated tool, but it's still very good for what it's used for. It's just kind of used specifically for shells and things like that. So there's better tools out there for just transferring files and things like that.
Cool. Right. We are on to the next one, which is static ain't always noise. Right here. And wow, bash scripts. Now bash, can you tell me, like, while I actually set up the folder, can you tell me a little bit about bash?
Yeah, so bash is just the shell that you're in right now. So bash scripting is just literally commands. That's all it is. So like what you're doing right now, make directory, and then so on and so forth. You could do the same thing in a script, and then every time you run it, it's going to do that, right? So most of the time what bash scripting is used for, or what it's designed for, I guess, is system administrators doing repetitive tasks. It's the same as PowerShell, things like that. So let's say I take a backup every single day of, a certain folder. I can create a script that does that and then set it for a timer using cron jobs. So then it'll just every day it'll run that script. I don't have to retype it in every day. I don't have to retype it in. That's what bash scripting is really designed for. Again, if you're familiar with PowerShell, it's very similar as far as what it's designed for. But bash is just the shell that you're in.
So the bash, all you're writing really is a sequence of commands, and maybe
correct. Yep.
Maybe you're adding some sort of time delays or some commands to say wait until complete or something along.
So it could be as simple or as complex as you make it. So some people might write a whole bash script out that also has error messages that just like a program would, so that like if it doesn't work, it'll give you an error message and things like that. Or it could be as simple as it does this task and if it doesn't work, you won't even notice it. Bash scripting can be, again, as simple or as complex as you make it, but it's literally just writing commands and doing it in a format that it reads as a program, if you will.
Cool. So let's take a look at this bash script, ltdis.sh. Lots of comments. It looks like the comments work exactly the same way as they do in Python.
Yep.
And there is some object. It's not that long. So the idea is you're object dumping. There seems to be a text.
Yep.
file involved.
And it looks like they added some if then comments, if else. So like I said, you could theoretically, since it's just a bash script, if this was just for your own personal use, you're not distributing this, you really wouldn't even need the else because you could tell if it worked or not. So it's as complex as you want to make it, but if you're writing it for somebody, you should do it complete.
And when I look at the static, again, we have like a file that's got no extension. So like you've just gone into a directory, you're trying to figure things out, and you see that. What do you do? Like, what commands do you run to find out what static is?
To find out, like, well, first thing I would always do is cat it to see if it's a text file, right?
Okay.
So you can see it's got ASCII characters. It's a text file. It's got text in it. That tells me, looks like there's a flag right there. Actually, I don't know if that's the actual flag or not.
If it says CTF, picoCTF, that would be the flag.
It's right there in the middle there. It says picoCTF. So up a little bit, not in that jumbled, up just a little bit. Keep going, up another line.
Oh, it's up somewhere
just
here.
Down.
Oh,
yep, right there. Yeah.
Because I was looking at the bottom. All right.
Yeah. So it looks like all they did is kind of jumbled the letters, and then you had this decoding would find it. But yeah, so really it just depends on some will have extensions, so you can make it a text file. You'll see a lot of times in Linux and stuff, you'll have files called like .back. Those are backup files, that type of stuff. So Linux is kind of unique because a lot of the files, including the configuration files, like if you're, changing how your computer starts up, if you're doing, all of those are written in text. So almost every file in Linux, unless it's a program or something that's executable, will have text that's written in it. Every configuration file, the shadow file that holds the passwords, the password file itself, all those are just text files. So it's really, Linux is very much a text-based operating system that you can manipulate however you want.
Cool. So look, we have the bash script and the static. So let's try. I mean, we've already figured out the flag. I think there's probably like 5 ways to figure out this flag. I mean, if there's just some captured text, you could grep it. Like if I just walk me through this, because I've used grep before. So you do you do a text.
So you would have to cat it first.
Like that? Oh, I have to.
So the easiest way is just get rid of that and just type cat and then whatever the file name is.
Cat static.
Yep. And then hit space. Now hit the pipe, that straight line again.
Okay.
And now it's going to then funnel that into our grep. So now hit space and grep. And then you don't even have to put the quotations or anything. Just type in picoCTF. And then one thing I'll tell you is that it does require proper uppercase and lowercase on this. So then just hit enter and you should be good to go. And it looks like, there you go. So it's a binary file. So you could actually use strings to do the same thing. So you could type.
This
you
is
could
weird,
just type
though.
Strings.
I've got a question. It says, like I've used grep before, and it actually spits out everything that's longer than 4 characters that has that substring in it. But now it just says it matches, which kind of means that it's there, but it's not printing it out for whatever reason.
It looks like it's reading it as a binary file, which just is strange. I'm not sure why it's doing that, because it let us cat it before, right? We catted it once before. So you can try strings and then the pipe and grep and see if it'll pull the strings out of it.
I think if I just say string static, it would like print them all out, and then there it is. That's the flag.
Yep. So there's the flag again. So yeah, there's a bunch of ways to find it. I'm not sure why. They might have purposely made it appear as a binary file so that you can't just cat it. But we did cat it.
If we're here now, let's try to execute this bash script together with the static. We might So I guess the bash scripts, like everything else, need to become executable. So we're going to do the chmod on them, right?
Chmod. And you can check it with, you can always use the ls-la to see if it comes downloaded executable. Typically the more secure operating systems. So yeah, you can see it is not. Yep.
So
and you can do 766, and that will, so I would do 777 on this since it's not your machine, but if it's your personal machine, 7 gives all permissions, but the way it works is that the first number is root, the second number is like a privileged user, and the third, or a regular user, and then the third one is a guest, I believe. So basically 777 just says everybody can do everything to it. If this was my personal machine, I wouldn't do that. I would do like 766 so they can read and write it, but they can't execute it except for the root user. But I don't know if we have root access to this machine. So I don't know if we have sudo access.
We do not, but I think, look, let's see if the things turn green. Oh yeah.
Yep.
So now we can actually turn static. So now we run it, but of course the thing takes
it's going to need the script probably as an argument.
I think I messed this up because I've just made static the executable, and static is a text file. I should have made the.
Oh yeah, and that's fine. You can leave it executable, and it won't hurt anything because you're not executing it.
Cool. That's actually a good thing to know.
Yep. So and that's one thing. Oh, sorry. Go ahead.
Yeah. So everything's executable, but the actual properties of the executable static, I can read it like it was previously text. I could write to it like it was previously text.
Yep. You can always change it. And like that's what I was saying about Linux is you can make anything executable in Linux until you actually do the period / and execute it. It's not going to execute. It's not going to read it. Now, if you call upon it with certain files, it might try to read it as an executable. Oh, you put li, it's ltdis.
Okay. Ding ding, lt this dot show static. Disassembly is successful.
Available at. Okay, so it created a new file for you. It looks like.
Cat. And who knows which one it is, but let's try both. Static.
Yep. So if you just hit tab, it'll finish those out for you. That's the easiest way to know that you're doing it right.
That's probably not it. Let's try the other one. Tab. So we got not the x86 strings. And that's what we did. I mean, we effectively called a strings file, which is this. But this time we've actually used the tools given to us, which.
So it looks like they basically gave you a strings bash script that they created versus using it yourself.
I guess the sort of overarching thing that's coming out of these walkthroughs for me is that there is at minimum 3 ways of solving everything that are completely.
There always is. I'll tell you that. The biggest thing about hacking and security in general is that's the hardest part about being someone defending, and the easiest part about being on the offensive is there's so many ways in. You're just trying to make it secure enough that it's not easy. That's the key. And
it's a different mentality, right? Like I think if you're defending, you have to be very detail oriented. And if you're attacking, you have to be very you just have to be persistent. And it's almost by trial and error, you will stumble upon something that works.
And you have to think outside the box. That's the biggest thing. Because like you said, I mean, there's countless CTFs I've done and countless boxes I've done where, you finish it, and then there'll be times so a lot of times I'll finish it and then I'll look up what someone else did, and it's totally different methods of how we did it. And we got the same result, but it's a totally different method. So it's not uncommon that just because you did it this way doesn't mean that that's a wrong way by any means.
This is, and again, I hope that people watching this are are getting that part out of it. Every single one of these is a simple mission of doing a task that hackers come across almost every day, that can be done with different tools. We could have probably done all of these challenges without using the command prompt by downloading files and using online tools.
Yep.
I guess the core idea here is to use the most commonly used tools and build some skills. Okay, Magicarp ground mission. Let's find that one. 89%. That means this one's popular. So launches an instance on demand. Like when you hear these terms, like again, what does that mean? Is there like an
instance? Yeah, it usually means they're going to spin up it depends on how the website's set up, but usually it means they're going to spin up a VM that you can then well, just because I know what this one is, that you can SSH into is what they're going to do. They're basically going to run a lightweight SSH server for you.
So again, that's a lot to unpack here, right? Because like when you say server, okay, that's a computer designed to give other computers access to files. Yep. But then if this thing is away from me on a separate network and I'm SSHing into it, like does that server now need like a modem to allow other machines to connect into? I guess even that could be virtualized.
Yeah, so especially nowadays in enterprise environments, almost everything's virtualized in a way, right? So the key thing with virtualization I try to explain to people is, so let's say you own a company and you have a server room and you get a bid and you realize it's way cheaper to have it all go virtual, meaning it's going to sit somewhere else, right? You're not changing anything. Those servers still exist physically. They're just, you're not managing them anymore. You're paying someone to manage them. So someone like Amazon buys a huge warehouse, they fill it with just hardware to the brim, and they say, give us, X amount of dollars and you can run your servers on our stuff. So they're taking the risk of physical damage. They're taking how much it costs to run the power, the cooling, all that stuff. They're taking all that, and then they're basically charging you rent, if you will, on these servers. That's really the virtualization is just a win-win, because someone like Amazon can scale it big enough to make enough money to cover all their costs and so on and so forth. Whereas you might have had 20 physical servers sitting there, and realistically you're not using them because you might have a file server that's running at 10% CPU, let's say.
Yep.
Well, now you have 90% of that CPU being wasted that you're paying power for, you're paying cooling for, all that stuff. Whereas they aren't wasting any time. They have load balancing and stuff like that that's going to make sure they're not wasting any server space. So it's really just a way of saving money for both people is all it is. But they're still physical servers. They're still sitting there somewhere.
Cool. So like when I type in this command, so SSH secure shell, that means that the requests I sent are encrypted and the information they send back, that's also encrypted.
Yep. So you're requesting a secure shell. So you're requesting a secure connection. So this, you want to say yes. What this is the first time you ever log into an SSH server or just a computer that's running SSH, it's going to ask you do you want to connect to this? The reason it's doing that is because it doesn't recognize that computer or that server or whatever it is. And so it's basically asking like, hey, is this okay? Is this what you're trying to connect to? The reason that's important is because if you click yes on it, it'll stop asking you after that on your computer. So if every day you come into work and you SSH into a server and every day it works great, and then one day it pops up and says, hey, are you sure you want to connect to this? You've never connected to it. We don't notice the fingerprint. It probably means someone is man in the middle. Someone is pretending to be your server because you already had that established relationship with it, and now you don't.
So the absence of this warning in a connection that you normally make is actually the calming thing. And if it pops up out of nowhere, that's the red flag.
Yeah, once you hit yes on there, your computer saves that fingerprint. It says, when I connect to SSH, it says, okay, we're good. That's what we want. So
I'm just re-entering this.
Yep. So I can tell you, let me look at it. I was looking here. Oh, it looks like you got in there.
We're in. And
okay.
So like this I really look forward to, because this was a bit weird.
Yeah. So you're actually on a different machine now. You're now 100% on a different machine. You're not using your machine anymore.
So I've got some things, because I've solved this one before, but I never really understood why. Have a look at the terminal. So I'm just going to go through, like, there's part one of the flag, right? Cat one. So here we go. We've got a portion of the flag, and we're going to put that there. But now I'm just going to read the instructions. So we're going to say cat ins. Next, go to the root of all things. So now we're going to go to the root. Now I have on my virtual Kali Linux gone to the root, and this changes. When I change folders, the actual user at domain or machine has like a change of folder, but like this is not showing me anything. So now if I ls.
So do the CD again. You did okay, you did actually change. So yeah, so there's 2 of 3. So all you did, I don't know who, type in who am I? I'm just curious who it logged you in as. Okay, so you're just CTF player, so you're not root. So it didn't change on here. You're saying on a regular box it changes, is what you're saying.
It always, right? Like when I change the directory, when I go into root, it says root. If I go into something else, like I am seeing the directory.
Yeah.
Here.
That's just a setting. That's a setting. You can change that completely. Some people don't even have displays there. Some people take those off. So it's just a setting. You can display what you want there, whether you want it to be the user. Normally when you SSH into something, you notice how it says CTF player at picoCTF.
Yeah.
A lot of times that at, so before the at is the player, and then the picoCTF is what you're connecting to, typically.
Yeah. So I guess the answer to my question is what appears as text here is actually configurable.
It's 100% configurable. Yep.
And it's configurable by the person whose server or directory it is.
Yeah, whoever's the admin for it. Like mine on my box says Stuffy at Parrot, but my old one just said Stuffy. I took away the at because it just was easy.
Right.
So it's just all configurable. Some admins also will purposely put kind of information there, if you will, like if you're on a military network or something, they might put in there at military or something, so that way you know where you're on a military box or something like that. So it's just all of kind of a preference.
Fair enough. I just do not understand the preference of why it doesn't say home here, because I'm changing directories. And this thing should tell the user that the directories are changing. It's like as if I'm in the same directory the whole time.
Normally it would, on like you said, on your box it would. When you're connecting to an SSH, it's normally going to stay that way. But the biggest thing is whenever you're trying to figure out what directory you're in for sure. So whenever I change directories, I always type pwd, it's present working directory, and it will tell you where you're at every single time. I always do that. It always shows it.
So the only tip of going through this again would be to have NC. This was just at home, and this is home CT. Yep. So like if I was to do this challenge again, and if I'm advising people in the walkthrough, if you're SSHing into a server and it's not showing you the folder you're in, just use the pwd a lot. And
that comes into play big time with hacking. Because what happens a lot is when you actually connect to a box, sometimes you won't even get a prompt. You'll get nothing. So sometimes it just shows a blank screen and you'd start typing. So it just depends on your shell. So that's kind of something that will throw you off, right? You'll connect, you'll just be sitting there waiting for it to do something, and you're actually on that box. You just don't notice it. So you start typing and boom, it'll give you feedback. But so it's just kind of, that's why those commands like pwd and stuff are very important to learn. Here, I think the big one they wanted you to learn on that last one is that little squiggly line key. That's always home. So if you're ever trying to figure out what your user's home directory is,
And
that's a shortcut for home.
And basically I could be in any directory and it
Yep.
will take me to home.
It'll always
from
take
here.
you home.
Very good.
Yep. And usually it's users, then your username, and then home. But again, you can set that configurable so that, let's say when you create a new user, they always are in the root directory as home or something like that. You can always set that up.
That's like, honestly, I think this has been probably the most useful sort of walkthrough for people trying to get into CTFs.
Yeah.
Because this was the most, like, this I found very easy, but the most bewildering.
Yeah.
Because I did not see the directory and I'm like, I have no idea. I'm typing in commands and all of a sudden I'm going into different folders.
Yeah.
I'm blind.
It feels like you're not actually changing directories.
Yeah. But it's very straightforward. I did not know that this was, I did not know that this is like entirely configurable by the people whose machine it is, which.
Yep. And SSH, like I said, normally SSH will stay there. The reason it does that is because it's kind of showing that connection through the entire thing. Like you notice that yours is there at the end. It shows the /GS. You know, so it shows the home, the squiggly, then /GS. Like that's what you were saying is it shows that. Like on mine doesn't show that. And the reason is just because I just don't like having a longer one there. I like having more screen space, so I take it off.
Interesting. All right, let's get back into it. We are looking at a series of challenges that have to do with basically data encoding. And the first of which is let's warm up. And it basically says, if I told you a word started with 0x70 in hexadecimal, what would it start in ASCII? The hint is submit your answer in flag format. So we're just basically going to write picoCTF in the answer. Now, a couple of things here. Just to clarify, the 0x I've seen as standfrax ASCII in Python programs, but that is universal.
Yep. Yeah, that just is basically a delimiter to let you know that it's starting there.
And like where, I mean, again, like this is obviously colors is sort of a series of 3 hex digits that go from 0 to 255. But where, like I've seen it for colors and memory locations, is there anything else you see ASCII, hexadecimal in?
Yeah, you'll see it in a lot of, like you said, programming. You see it in programming to specify different things. You'll see it in, sometimes you'll see it in backend configurations and things. If you really dig down into that deep into configuration files and stuff, sometimes you'll see it. But really the big thing is, especially with how easy it is to convert, is being able to identify it. If you can identify, like you said, with the 0x70, if you see a lot of those, then you can kind of identify that's what you're trying to look for. And then here you'll show how to actually convert that.
I remember that I did it. I barely remember anything from it, but I did machine language, like basically microcontrollers that go into registers. And I have seen, like, that's the only place in uni I've seen like hexadecimal numbers. Okay, so like for this, you're going to use a converter, and we'll do it for you. This online hex tools was the only one that we found that basically does 0x70 straight into the letter P. Because what really goes on is right here. You enter the hex number, you're going to get a decimal number, and then you could take that decimal number and go from decimal, or should we say ASCII decimal to char, something like that. Convert decimal to ASCII. And what was it? Oh yeah, 112. So I used this one before, and 112 is the letter P. So I think you type in picoCTF P. And for people out there doing this, just be aware. We'll put this in the link below. I mean, Rapid Tables is probably the one-stop shop for your conversions. And in this particular conversion, you're going from hexadecimal to decimal, and then decimal to ASCII. That's the first one done. Second one, warmed up. Well, right here. 0x3d. Okay. Like D is like 16, 3 times 16. Yeah, I could do this in my head. Actually, a fun activity I set up for my students last year when we were doing cryptography and data encoding was they were creating their little Python quiz. And so they created like a quiz script that quizzed them on binary encoding and hexadecimal encoding. And I had kids that could like call out 0 to 255 immediately. Like, but I can't. I don't know. Like D is 16 and 3 is, I think 3 is in front of it is 48. So is this, am I right? Is this,
let's see, 1648. You're close.
56, not, 66.
It's 61.
61
is what the actual answer is. But you're close.
All right.
You would know that portion better than I would, because I don't program enough to have that memorized.
No, I don't go like Python's like too high level. It just doesn't get into the muck enough. But yeah, let's find an online converter that's going to take you there. So sorry, that was warmed up, and the number was 0x3d. This should be very easy. Like let's try this in rapid tables. So if I go back to rapid tables, we go conversion. Let's see if we can find this number. And we are looking at hexadecimal to decimal. Hex decimal. Great. And hex number is 0 then. There we go. 61 in decimal.
Yep.
It's very good to just try to use one, even if it's a little clunkier. If one website has everything you look for, you just get used to that, and then you'll be more efficient. So I think rapid tables, if hackers recommend rapid tables, I would recommend if you're doing this for the first time, maybe just get used to that website. Too warm. Can you convert number 42 base 10 to binary? Okay, we're literally on the right page for that. So let's just keep it simple. Decimal is 42 and binary is 1010. And if you want to do it in your mind, so it's powers of 2. So there's 0 ones and there's a 1 2. So far we got a 2. And then there's 0 4s, and now you got a 16. So you got 2 plus 16. There's 0 32s. No, wait. 0 1s, 1 2, 0 4s, 1 16.
You forgot 8. That's where you're missing one.
Right. And so this is going to be a 2 and 8, that's 10, and 32 is 42. Yeah. Let's enter that.
Yeah, I usually have to write it down binary, but
yeah, 10. Apparently, Alan Turing did massive calculations in binary, without a computer, and I just find it impossible to even imagine how you tune your mind, to think of numbers on any other base. I mean, like what we do is like base 10 is arbitrary, maybe because we got 10 fingers. Like it's as valid, like from a logical perspective, as any other base. And yet it's so hard to like get your brain to think differently.
Yep, I agree.
11 bases. Okay, so this was interesting. Like I was clueless when I first did this.
The bases.
Yeah. It might be on the next page. Like, let's see, bases. Yep.
Yeah, and this one to me, so it's funny because to me this one was one of the easiest ones, and it's worth 100 points. And then it's just funny because that's what I thought, and then you said you were clueless on it. So it's like this one. This is just from my perspective, but like just the name alone told me exactly how to beat it. I knew exactly before I started how to beat this one. So it's just kind of interesting to see the two different dynamics.
Yeah, but like for me, okay, I kind of knew the ideal here, right?
Yeah.
So this was going to be some other base, and then you can and the base has got to be higher than 10 because we're using characters, right? So like the next one up is hex. So I kind of had an idea of what it was about.
Yeah.
but I didn't even know that there were bases above hex, and like, why would you use them? And like, are you serious? Like,
yeah. So I can tell you why we use a lot of those bases. So I'm trying to see if either of your URLs have it up there, but it doesn't look like it. But basically, what you'll see a lot of times is like, let's say you're logging into your bank account, right? You'll log in on the site and it'll say like bank.com. And then if you don't encode it, what it's going to say is like bank.com and then user equals, whatever, 1, 2, 3, 4, and then pass equals 1, 2, 3, 4, whatever. And it's going to be a long string of characters, right?
mm-hmm.
Well, the reason we encode that is for a couple of reasons. One, URLs, you don't want them to be, a million characters long. So it has to be shortened down. The other reason is if you send that over to somebody, it's going through the internet. So anybody can grab that. So it makes it much more difficult for someone like me to do basically what we would do is then go to that website, log in, and then so let's say my username is encoded, but it's called, user123. I can unencode it, change that user123, intercept the packet, and put user234, and then re-encode it and put it back and see if you'll accept that. So what it does, if you encode it, it actually takes a form of basically non-repudiation in a way, but also validation. So it knows what to expect. If you change any of the bits, the encoding doesn't work, right? So it won't take if it's encoded. Now, what I was talking about with decoding it, changing it, and then re-encoding it, that's de-encapsulation. That's its own attack. That's what people do. But the point of encoding is to make sure that whatever you put in there is what's supposed to be in there. Because obviously, if you change it and encode it, it's not going to make sense. So that's really the main purpose of it. Sites use it all the time. There's URL encoding. There's all kinds of encoding, but the main uses of it are still the same principle across the board.
So like, here's my approach, and you tell me if it's valid, because I don't actually remember this question. But I'm going like, okay, so we're going, it's probably, most of these encodings are going to be powers of 2. So I'm just going to go to 32, 64, 128 and hope for the best. I mean, like,
that's actually a really good thought process to go with.
Okay. Base 32 decode.
Yeah.
And let's see what happens. I'll go input invalid base 32 characters. All right. Base 64 decodes. And then I'm going to paste that same thing. Decode.
And I can tell you, learn the rope.
Learn the ropes.
Yep. So I can tell you, the main reason I knew before I even looked at the question is because you'll see, especially doing CTFs and stuff, you'll see base 64 encoding all the time. It's just all over the place. It's probably the most common encoding that I see in CTFs and things like that as well. So that's why I knew that.
How would you recognize it? Like small capitals and little letters? Because like,
yeah. So I don't know it well enough to know if there's an actual distinct pattern like that to recognize it. I'm sure there is if you studied it long enough, but I actually just would put it in something like CyberChef and check it. But like I said, the name is what really gave it away here. I didn't really have to think too difficult on that, but I'm sure there is a pattern that gives it away.
Well, look, check this encoding right here. Look. We've got, it goes numbers. It starts with capitals. And then uses little numbers, and then
it looks like as it gets,
it's got numbers at the very end with plus and dash. So if you got small letters, capital letters, a plus numbers, or a slash,
and that's it.
Those would be the sort of shorthand hallmark. So like, go to Wikipedia, check out base 64, and like, you'd be, I mean, Stuffy knew it from experience. Like, he looked at it. And if you kind of want to shortcut some of that experience, just check this table out. And I think it's a good shorthand for recognizing it.
Yeah, absolutely.
So these have all been like away from the shell. So let's see, we've got Convertme. Oh, Convertme.py. Well, that was. This was interesting because it combined shell stuff with encoding. Convertme. All right, 100 points, 76% like lots of clues. Okay, so like if I think it was GS this time, cdgs, and we were going to make a directory called Convertme. All right, cdcn, and now we're going to wget the Python script that they got there. And now, let's see, it's called Convertme.py. If I cat it, let's see how long it is. Okay. So you're converting some hexadecimal numbers to characters. I mean, the character, like this seems, but there is an XOR. You've actually, yep. When we talked earlier, you mentioned that this is sort of like, yeah, these types of things are fairly advanced encoding. And this time it doesn't use any sort of algorithm from FairNet. Mm-hmm. It kind of does it from first principles. Yep. And it uses this XOR, which when I first saw it surprised me because like, logic gates, they're, in my brain, they're associated with like, making transistors, like scale up into whatever, some type of a low-level logic circuit. But yeah, so what's roughly going on here?
Yeah, so really, this is just a very primitive encryption algorithm. Is basically what they're doing. They're taking the secret key, right? And they're XORing it. So what that means is when they break it down into binary, they're comparing it to something else, the key. So they're comparing the message with the key, and then they're XORing it, meaning all they're doing is looking for a 1 or a 1 in one of the categories versus, so they're comparing the two, ones and zeros. If it has a 1 in one of them and not a 1 in the other, then it turns into a 1. If it has two ones,
0, 0, yep. 0, 1. Sorry, 0, 0, also 0.
Yep. So 0, 0 and 1 are 0, but 1 and 0 is 1.
Yeah.
So, cool. And it's doing that the whole time. And then you can see there the flag encryption. They've actually specified specific characters, strings and things. So really all they're doing is the XOR just makes it to seem more random. It's so that you couldn't necessarily look and find the pattern, or it'd be more difficult, take you more time. XORing something one time wouldn't really make it that difficult, but in modern cryptography, they XOR it and then they do maybe 16, 32 rounds. I mean, it's going to be a lot. So it'd be a lot harder to notice a pattern versus here. We could probably, if we really spent a lot of time on it, we could find a pattern.
But the actual question itself is very easy. So we just need 68 in binary. And I mean, we found 42. I am not going to suffer my way through this. And we're just going to type in 68 and that's our binary number.
Yep. Yeah, so here they just kind of mixed a couple of different things we learned.
And here we go. This is our flag. But yeah, that was one thing that I guess comes out of it, even though we don't really cover it in theory, maybe we will in future videos, is just the use of XOR in cryptography, because you have come across that in CTF challenges.
Yeah. So modern cryptography cannot, I don't want to say cannot, because I'm sure there's someone out there that could possibly do it, but it cannot be broken by human brain. It's the algorithms are too complex. So you'd have to have a computer and understand the algorithm, but the concepts are all underlying the same. They've been the same concepts since probably the 80s is one of the newer ones. but realistically, they've been the same. RSA was invented in 77, I believe. So it's been around the same concepts forever. They just keep adding more rounds and realistically XORing at different times and things like that. The concepts all remain the same. They're just trying to find ways to make it look less random so you can't find the patterns, because the real issue
You
with
mean,
cryptography.
sorry, you said make it look less random, make it look more random.
Or yeah, I'm sorry, I did say yes. I meant more random. Yes, yes. So the problem with modern cryptography, right, is if you created an algorithm out of your head, or I did, or something like that, it's going to take someone a very short period of time to break it, because nowadays everyone knows that the most common words, single letter words, are a, single or 3-letter words are the, that type of stuff. So you can start to pick those out of large text that we've encrypted, and you can start to say, okay, that's probably a or I, and so on and so forth. And then from there, you can keep breaking it down. And that's why they've gotten so complex, is because you can do the same thing with decoding it on a computer scale, is look for patterns and start breaking it. So therefore, if they do more rounds, it makes it harder. If they make longer keys, longer blocks and things like that, they're encrypting at a time, it just gets very, very, very complex.
If you basically want to substitute a character for a character or a series of characters, or you want to do something that your brain can wrap your head around, the only thing that's going to work is probably like some kind of a one-time pad. Everything else, not so much.
Yeah. And if you want to understand the basics of cryptography, Caesar cipher is always a really good one to start with. ROT13, those type of things. They're very basic algorithms that have been invented since the 1400s, and they're really good to just kind of understand what's going on.
There's a lot of websites around that, and like there is a cryptography section that we're going to get into, which I look forward to. I mean, I personally have solved about half a dozen or maybe more of the challenges, and I found that I found like sort of the RSA public key, private key stuff hard to break. There was even one I figured out that a website took about 8 minutes to crack, and when it didn't come out in 5, I just gave up on it, and then I looked at the solution, and I'm like, no, I figured it out. I just didn't wait long enough. So those are going to be interesting, because it's not even. At some point, it becomes not even about being able to break it. It's about efficiency, because if your method of breaking it is going to take 3,000 years, you need to try something else.
Any algorithm is crackable over time. It's just a matter of time. Like you said, that's the same reason. One of the questions I get all the time is, why do we change our password every 60 days? That's why. Because if your password does get leaked, it's going to get leaked as a hash, which is encrypted, and it may take them 60 days to break it. So
it may take them 3 years, but
exactly. So by time they break it, you've already changed it. So that's the whole reason of changing it, is because it may get leaked, and we know it probably will over time, but this way it won't be valid by the time they break it.
This is a question I have to ask a hacker. Do you use a password manager, or do you just have exceptional memory for passwords?
I do a little bit of both. So I do use a password manager for certain passwords, but there is passwords that I have just from working in this career for a long time that I know are secure, but also are a way for me to memorize them, if that makes sense.
So you actually put mental effort into memorizing passwords because the security benefits are worth it.
Yes, because I have seen people lose a password manager, or have that password get guessed to get into the password manager, and then it's like, well, now it's all broken.
Right. Yeah. I struggle. Passwords are a personal struggle of mine. I do change them you said 60 days. I do them roughly 6 months to a year.
Yeah.
My main, like, I have all my passwords saved in Google, and I have like a 13 character password, like a pretty hard one to get into my main Google account.
Yep.
And then Google Chrome saves everything else. And that's the one that I keep changing. And so But no, I don't know if you call it password hygiene. Yeah, I need to step my game up on that.
I'm sure you'd be surprised because every year they release the most commonly hacked passwords, and every year they're about the same. They don't really change. Password 123 is still up there. I mean, you'd be surprised.
That's funny. Okay. So we have finished with the collection of the sort of encoding challenges. And now we got strings. And this is interesting because we have used strings. And this is like the ultimate shortcut to extracting text out of. Is it mainly executable programs, or is it just like pretty much any files? Like
it's pretty much any file, yeah. It'll look for it, but it's supposed to be for binary files, but it will look for strings in anything. That's the whole purpose of it.
Will it have any success in like a zip file or something like that?
That's a good question. I believe it will, but you'd probably have to uncompress it first, because it would have to uncompress it by itself.
Right. So let's create a thing like there. ST. Okay. So now we're going to wget this file. And there's something that I saw in other walkthroughs, and I want to ask you about it. So now, like, we've got strings, and like I've seen people write file strings. So what exactly does this tell me? Like, what's the useful information that comes out of that? Like,
yeah. So, well, for one, let's see. So the file strings, so it's telling you, number one, what kind of file it is. You can see it's an ELF file right there. So ELF is an executable on Linux. I don't know if you're familiar, but basically it's like on Windows. Yep. On Windows, you're typing .exe. On Linux, if you ever want to make so you were asking earlier about the actual not having those actual extensions built in, right? Well, you can add the .elf, and then when you download it or whatever, it will come as an executable on Linux. You don't have to add that extra executable permission that now some machines will by default just not allow that, and then you'll have to add the executable, but it comes as an ELF file, which means it's executable. The x86 just obviously tells you what bit. Dynamically linked, that's not important here, but yeah, it looks like really it's just giving you basic information about it. It looks like it's SHA-1 encoded, not striped. Yeah, it's just basic information about the file.
Okay.
So you can see permission denied. That just means that we never gave it the executable permission.
Okay. Now so by looking at it, I would have thought something along the lines, this is an executable. Maybe I should try executing it.
Yep.
But the whole notion here is that we're going to use strings, which is a the word you use is definitely not a function or a method. It's commands, right? Like strings is a command.
Absolutely. And you can also still run this file. You just have to add that permission to execute. It's a default Linux thing that when you download a file, it's not going to allow you to execute it by default.
Now this is like terribly named. That's the thing that I hate about this challenge, right? Like typing in strings makes me feel like, what? But no, this is a Linux command.
Yep.
And this happens to be the name of the file that we downloaded, which is an ELF executable. Yep. And it's going to print out all the strings within that executable file. Yep. And one of these strings,
you can, just to kind of throw together, add things like we've been kind of building upon. So you can do that same command. So just hit up, and then you can use a pipe and then grep and the picoCTF, and it'll give you just the picoCTF line. So that's a way that you can kind of build upon the things that we've been doing. So you'll need the pipe.
So like I was just going to show you this, right?
Oh yeah, that'll write to that file.
Clear. So I'll show you how I solved it myself. So it was like strings, and then this writes it to output output.txt, and it creates output.txt for you. So if you go ls, and now I go like nano output.txt, and it was pretty bad because like I think I tried Control F or some shortcut, but this time instead of like disappearing in the noise, it was one of them. I don't know if like Control F would find something, but not the best method. But it worked.
So and that's really the key, is if you can get it to work. Like you said, there's 5 different ways to beat all of these. So,
but we want to do the pipe. So
well, the easiest way that I would do it to save yourself time and not having to create a file would be the cat. You can do the output. You can cat the output since you've already saved it to it.
So one second. I think now that I know how to use Grep, it's like this output.txt. I'm pretty sure this is gonna. Yeah.
There you go. Now, so the only difference, because that's exactly what I was saying. The only difference I would have done is, just to save steps, is instead of writing to the outputs.txt, you could do the strings and then pipe and then the grep command, and it would have taken that strings instead of writing it to a new file. It would have just automatically grepped for that picoCTF.
So let's do that slowly and unpack it, right?
Okay.
Because basically, first I'm calling strings on this file strings, and the output of that is going to be like 500 lines of random text. It's going to be
the same as that output.txt file you showed.
And I'm feeding that output as input into, this is like the pipe, like the output of this process is going as an input of the next one.
Exactly.
And I'm sending that into, you said grep?
Yep, into the grep.
And then
the peak.
Oh, then I'm going to do picoCTF.
Yep, and the picoCTF, and that's it. And there you go. You get the same results. You just didn't have to save a file.
And yeah, that's way better. Excellent. So like I've really got to get, again, it does take, I think it takes a little while to get used to the piping, but I can I could so imagine this like over a year saving many hours.
Yep. I definitely recommend learning the pipe, and really it's just learning Linux. Linux as a whole has its own mannerisms of things that you can use to your advantage.
So like we got first grep here, that's the next challenge. And I'm just gonna get out of here, and I'm just gonna make their FG. And then we're going to wget the file here. So can you find the flag in the file? Okay. So I would imagine that this file they're talking about would be full of stuff.
Yep.
Would be really too tedious to look through manually. So if we went cat file, yeah, I mean, they're absolutely right. So somewhere in there is our flag. And if we basically say grep, and then we're looking for, even if we just typed in pico, like you don't have to, it's like a substring of the whole thing, and you say file. Is there, I mean, I imagine there would be a dozen frequently used sort of attack parameters here. Would you bother with anything, or this is pretty much?
If I was just looking for that, then I wouldn't even mess with it. I just do exactly what you just did. Just because it's simple, it's easy. But there are ways. So like nmap's a good tool that hackers use all the time. Like when you're using nmap, right? The results come in a format that is not considered greppable. You can still grep it. Right. And it will give it to you, but grep will show you the line, right? That code is on. So if nmap doesn't separate it by lines, you're going to get a lot more information than you need, or a lot less information. So what nmap does is they have a greppable format, which then when you look at it through cat looks really crappy because it's like a bunch of lines and stuff. And what it is when you grep something, it will show you every piece of information you need. So if you grepped an IP address that you scanned, it'll show you all the scan results. So that way you can break it out that way rather than you would have to grep, the IP and then the next line and the next line, next line. It puts all the information on one line for you. So that way when you grep it, you pull that out. So it's good to know what format grep uses, which is it pulls the entire line that's on. So that way, if you're creating a file that maybe you want to, or a piece of code or something, or a bash script, and you want to be able to pull a lot of information out, make sure you put all that information on one line. And that's what we call greppable format, even though.
Right. So you're basically saying that if the information isn't saved in a way that distinct pieces of information are in separate lines, then it's not greppable, meaning grep is going to give you probably way too much. Or perhaps if what you're looking for is on multiple lines, it'll give you too little.
Exactly. Yep.
Right. Right.
And I mean, technically it's still greppable, right? But that's just what they call greppable format.
Cool. So I think as far as what we've planned today, we are on our very, very last challenge, and that's going to be the code book. So I'm just going to make their CD. That's what I'm going to call it. CDCB. And there's nothing in there. I'm going to search for code book. And this seems to me like there is some type of encoded text and some type of a decoder, and we run the decoder on the encoded text. But it'll be interesting to actually take a look inside at both the jumbled text and the decoder file.
This is what I was talking about earlier when I was saying that one of the first things I used to teach the students was to create bash scripts. I would create a bash script where they did this exact thing, where they would create their own encryption algorithm, whatever they wanted to do, whether they wanted to use a Caesar cipher or whatever, and create their own script to encode text and then their own script to decode text. And then all your friend or whoever you have the file would need is the secret code word or the secret number or whatever the case is. And that's what this is doing, except for obviously they already have the secret code in there.
Right. So
but I believe this is just a substitution cipher is what it looks like based on the I looked at it earlier and I noticed, or I counted out the letters. The letters are the same on both the encoded and decoded, which tells me it's a substitution cipher.
Right. So like if I'm looking at it again, it's new key plus I. So it seems to be that there's an XOR, but it does seem to be going for character by character.
Yep.
I'm guessing
you can see if. Oh, sorry. Go ahead.
I'm guessing as you iterate through the script, the key is the letter of that code book. Yeah.
Yeah. And if you look at the flag encryption, if you read or if you count those out, it's the same number of characters as the actual encrypted text as well. So, like you said, they're going character by character.
Yeah. Where did you see the encrypted text? Because
I just noticed it when you catted it.
Okay. Import sys. Oh, flag. Yeah. Okay.
Yeah.
Interesting.
So that's the same amount of characters, which tells me again, like you said, it's going character by character.
Cool. So I think all we need to do is, let's just run. Let's clear that and run Python 3 codes.py. And
there you go.
Puts it out.
And you notice too with Linux specifically, since it was a Python, since you're using Python to run that script or that application, you didn't have to change the permissions on it because Python is using it to run rather than running it straight as an executable.
That's yeah. I mean, in a way, are there any other? I know Python's an interpreted language, which basically means you do not have to compile it to run it. Is there any other languages that are interpreted that are commonly used in hacking or?
So it just depends. JSON's a big one, but I wouldn't say it's necessarily used commonly in hacking. It's just a lot of like AWS uses JSON. So
wait, wow. So JSON has like commands. I thought that it was just a format of storing data, like nested dictionaries.
It is, but when you start getting into the systems, like, so let's say you, for instance, SQL is just a database language, right? But you can use it to manipulate the data to pull it out, even if you don't have proper permissions or something like that based on misconfigurations. So even though you're not technically hacking, right? You're just taking advantage of a misconfiguration. You can use those languages to your advantage if you know they allow or disallow certain things, or don't have input validation or things like that. You can use them to your advantage.
Very interesting. Look, Stuffy, I think we've done 15 in one go, which I think is great work. I think over time they get harder. So the sessions are going to have less, probably like 9 or 10.
Yeah.
Thank you, everybody. Like, if anybody sat through this in one go, wow. But I hope you guys come back, because there's going to be a lot more picoCTF walkthroughs. We really are aiming to be the most useful, beginner-friendly CTF walkthrough playlist that's going to be out there. All right. Thanks, everyone. Bye-bye.
Absolutely. Thank you.